Welcome to screencast session on week 6 improved Kruskal algorithm. So this is a part 2. Earlier we have implemented a part 1 making a new data structure union find. With the help of union find data structure we have improved Kruskal algorithm now we are writing. So let's do the initialization part of it. It is taking that as usual that uh, existential list as a parameter. So let's do that initialization part of it. So we have a initialization of edges and tree edges. So let's do the both of them are simple lists. So what it contains is that empty list. So both of them are empty list. Now we are trying to do that. So making the distances as a tuple value. So that's 3 tuple value, but distance is the primary value or first value for the sorting purpose. So we do that in the W list of available keys, whatever keys are available. So that keys, each key we are getting into U. So then edges we try to append it with distance is the first tuple value, and then U is the second tuple value, and then the V for each V and D. So inside of that, so W list of that U. So whatever W list of U is there, inside whatever the distance is there, distance is used as the first parameter of tuple. So let's do the sorting. Already edges are available. That edges sort we do. So as you know, the Kruskal always selects that ascending order of that edges, so that Kruskal can work it. So we create the instance. So the instance of that union find data structure, already available class is there. The instance is created. So now do the singleton components we are creating using a predefined method. Earlier in the part 1 we have implemented. That's make union find, calling the method. So that method, what it will do is it will create that singleton components with the length of that adjacency list which you taken as a parameter. So now the singleton components are made with the help of that available method. So let's do the iteration for each distance U and V available inside of your edges, because edges is having a 3 tuple value. So in this we try to stop that. So as and when the U and V size is more than that total vertices, but before it, so you have to do the Kruskal kind of checking where that adding of edge, it doesn't create a cycle. For that, as usual, that mf dot components U, whenever U and V it is trying to merge it, they should not create that any kind of cycle. So the U is not equal to the mf dot component of V. So that means no cycle is created. When no cycle is created, we try to make a union method. Already union method is available, U and V. So as you know that making union is that whether that U is bigger or V is bigger, based on the sizes it's going to merge. So the tree edges, or we can say that MST edges, are appended. The edge is appended in the format of U and V, and as well as the distance, a 3 tuple value. So now checking of the stop condition. So the stop condition clearly it checks that if the mf dot size of the particular mf components of U, so it might be greater than or equal to the mf dot size of mf components of V. So whenever that U is bigger than the V, so then we check it. So if my mf dot size of mf components of U, if it is reached to that the size of that adjacency list, so maximum if U is reached to that size of the list, simply we'll break it. Similar way, you need to check the else condition for V also. So there is a second condition is there for the V. So we do the copying where V is there. If it is reached to that more than size of that, so adjacency list size, so then we type to stop it, because that union merging is finished. Finally, what do you do that we return the tree edges or MST edges. So let's run this. So this particular main driver or main program code is same. Earlier whatever that graph is used for Kruskal, same input was taken with 3 tuple value. So let's run this. So we have the generator issue where it is sorting. So maybe sorting, it requires that 3-tuple value. Yes, we have taken. So 3-tuple value, we try to take it where it is, it is comprehension we are creating. So let's do the comprehension, then only sorting works. And here it is the comprehension. And then it is closing of it. Sorry, it is here. This is a tuple value. And then, yeah, got it. Hope it is okay. So there is a pending issue. D and U and V inside of V. The distance of the inside of your W list of U. Possibly forget the parenthesis. Okay, maybe you got the parenthesis around the target, maybe something like this. Yeah, because it's a 3-tuple value, maybe tuple is expecting. Oh, got it. 3. Unpacking of D and U and edges. Yeah, it is a different line. Maybe it is unpacking. So during the time of unpacking, you required again that when it is packed they are together, when it is unpacked together. Yeah, it is there in 56 line number. Oh, maybe it could be here. Maybe something you can do it here, and there it is. Maybe there it is packed, here it is unpacked. Still it is where it might be that 56 line number, it linked to that inside of your edges during unpacking. Is it definitely required? Maybe distance of U and V and D. Still there is issue. Did forget that around that comprehension target. Maybe the comprehension which was created earlier is wrong. Yeah, it is, sorry, it is extend. I'm sorry, it might be extend because every time the list is extended by adding of a tuple, this time it works. So when it is unpacking is okay. That line number of 48, still there is a different issue. When it is extending, we use that V and V inside of your sense of it, 48 line number. When it is unpacking, we are using, didn't forget, maybe some issue at it is a pending process. D and U and V inside of your V and D of your W list of U. It is the edges, extending the edges. Did you forget that around that 48? It is extending. You got this. One for here, one for there. We got the 3 things V and D, but D we are taking as first tuple value. Maybe we want to give it this. Yeah, got it. So because that's maybe syntactically some issues there. So now you got that improved Kruskal algorithm output, which it contains that same kind of MSTs. You can check it that the particular distances are added in ascending order. You can check it the distance of 2 and then 5, then 6, then 7, then the highest one is added. The Kruskal is always selecting that edges in ascending order. So without creating cycle. So hope you understand. So thank you very much. Have a nice day.